Hello, this video is brought to you by Music Travel and More 1118. Please subscribe, like and comment for more videos like this. In this video, we will be reviewing ES.1 for the S Science Standards of Learning test. I am using information from the S Science Review for the Standards of Learning test packet from William Fleming High School and other information I have decided to add. You can follow along by watching the video as I talk and describe the images on the screen. The criteria for ES.1 goes as follows. ES.1. The student will plan and conduct investigations in which volume, area, mass, elapsed time, direction, temperature, pressure, distance, density, and changes in elevation/depth are calculated utilizing the most appropriate tools. B. Technologies including computers, probeware, and geospatial technologies are used to collect, analyze, and report data and to demonstrate concepts and simulate experimental conditions. C. Scales, diagrams, charts, graphs, tables, imagery models, and profiles are constructed and interpreted. D. Maps and globes are read and interpreted, including location by latitude and longitude. A. Variables are manipulated with repeated trials, and F. Current applications are used to reinforce earth science concepts. Our first topic is graduated cylinders. Following images are of graduated cylinders. A graduated cylinder is used to find volume by water displacement. This graduated cylinder contains 23 milliliters of water. I know that because I read from the bottom of the meniscus. A meniscus is the curved upper surface of liquid in a tube. This is a meniscus. You will read from the bottom to see how much liquid is in a graduated cylinder. Exactly where this line is. And not the curved upper part right here. Be careful when reading a graduated cylinder though, because it does vary in the amount it goes by. Not always, but a lot of them do. As you can see, this graduated cylinder goes by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, and this one goes by 50s. 50, 100, 150, 200, 250. Now, a graduated cylinder measures the volume of an object as well, and volume is measured in milliliters, which is abbreviated lowercase m capital L. As you can see here, I have dropped a marble into the graduated cylinder, and the water level increased. Doing this allows me to find the volume of the marble using a simple equation. Volume with object minus volume without object equals volume of object. Obviously, the marble isn't 13 milliliters in volume, so you must use this equation to determine its actual volume. The volume of the marble is 7 milliliters. I know this because I took the volume with object, which was 13 milliliters, and subtracted 23 milliliters, which was the volume without the object, and that gave me the volume of the object, which was 7 milliliters. Because 13 minus 23 equals 7. This works for abnormal shaped objects and things that are normal shaped, such as cubes and cylinders. These things have a formula, but abnormal shaped things don't have a formula to find out the volume. Even though these do have a formula, you are still able to drop them into a graduated cylinder to find out the volume. This works best with larger graduated cylinders if you have larger 3D objects. These are all reasons why graduated cylinders are very useful. Next up is a triple beam balance. A triple beam balance looks like so. You measure things by putting them on this pan and sliding these three sliding scales until it equals out. A triple beam balance measures mass. Mass equals matter, not weight. Mass is the amount of matter an object has, not its weight. This scale measures something completely different than the one you might step on in the morning. Mass, which is what a triple beam balance measures, is measured in grams, which is abbreviated with a lowercase g. Now, a triple beam balance has three beams. Beam 1 is the lightest in weight. It's in the front of the scale. It's a 10-gram scale and has 1/100th of a gram rider. Beam 2 is the heaviest in weight. It's in the middle of the scale. It's a 500-gram scale with a 100-gram rider. You can see them here, the scales with the riders and all. Beam 3, which is in the middle as far as weight, it's in the back of the scale and it's a 100-gram scale with a 10-gram rider. This means that a triple beam balance can measure an object that has up to 610 grams of mass, because adding them all together, 500 grams plus 100 grams plus 10 grams equals 610 grams, which is how much mass the triple beam balance can measure up to. The next topic is density. There's a lot on density, so pay attention. Density equals mass over volume. Now I have a way for you to remember this. With a hat, that is. If you look at a hat, it looks like an M with a V, and you can just slice it in half, as if someone were to break your hat. And that's going to give you density. So that's how you solve for density. Now, density is measured in grams over centimeters cubed or grams over milliliters. Another way to solve equations using density is with the density triangle. Seen right here. If you have the mass and the volume of an object and you're trying to find the density, you will use the density hat, or you could use this triangle. Mass over volume equals density. Now what if you don't have the volume? You do mass over density equals volume. And you're probably wondering, what if I don't have the mass but I have density and volume? You're going to multiply the density and the volume together, and you're going to be left with the mass. Now, the same substance has the same density. You might think, okay, so water has the same density as water. No. If you go to the Dead Sea, almost nothing sinks. This represents the difference in density between that and a pool, per se, or even a lake. There's a difference in density there. Now, if you were to have tap water and tap water, they have the same density. Okay, so increased mass equals increased volume. So the more mass it has, the more volume it has. But density stays the same. So if you have a cup of water and one goes to here and one goes to here, while this one has more mass and volume, they both have equal density. Now, if a substance is very dense, its atoms are packed together very close. That's why when seeing atoms, most solids, atoms are packed together, jam-packed right next to each other. While liquid have them a little bit apart, and gases have them way apart. So while a solid might be extremely close, the liquid is a little bit farther, and gas, well, it's really spread out. Now you might be thinking, well, when I put ice into my water, the ice tends to float. That is correct. Water is most dense as a liquid. Its density is a gram over milliliter. 1 gram over milliliters. Now, ice floats because it's less dense than water. And the reason for that is because when the ice freezes, air bubbles form inside of the ice. If you were to shake the tray rapidly while it was freezing, and it was able to freeze, more than likely the ice would sink to the bottom of the cup. Now, you've heard of warm air rising and cold air falling, right? Well, the warm air rises because it is less dense, and cold air falls because it is more dense. That is why heat rises, right? And so your downstairs is probably always really cold, and your attic is more than likely always hot and stuffy. So cold air falls or warm air rises. And the last thing dealing with density is if pressure increases, density increases. So if pressure increases, density increases. And the last topic is the scientific method. First of all, a hypothesis is a prediction about a problem that can be tested. A variable is a changeable factor, and constants are factors that stay the same. They stay constant. And the steps to the scientific method go as follows. Ask a question, form a hypothesis, perform experiments, analyze data, and make a conclusion. When forming your hypothesis, you're going to use an if-then statement, and you have to think to yourself, what do you think will happen? And when you're making the conclusion, you will restate the hypothesis. The independent variable is the one you change, as in I change. This variable is plotted on the x-axis, and you will see the I goes with independent, and the x-axis is this one. While all variables are changeable, the dependent variable depends on the independent variable. This variable is plotted on the y-axis. Another thing is if a scientific theory is valid, it stays valid when it's tested in an experiment, such as Newton's law. The law of inertia is the first one. I know we all know that one. As in, if something's in motion, it stays in motion. That stuff, all of motion. If not, it's right here. Yeah. Also, with the scientific method, I just wanted to mention different experiments. You could ask the question, I wonder what paper towel lasts the longest, for my hypothesis. If I test these brands of paper towels, then I think Brawny will work the best. You're going to perform the experiment, look at your data, and then make a conclusion. Like, when I did this, this happened, and I was correct. And for the independent and dependent variables, you would look at that and figure it out. Thank you, bye.